Welcome back to Big Data Now. This is part 2 of our PySpark and Databricks series, where we continue our deep dive into big data processing with Apache Spark. In part 1, we covered 15 essential PySpark examples, focusing on the fundamentals of working with data in Databricks. Now in part 2, we're moving to more advanced operations, including complex joins and window functions for analytical queries, handling nested and unstructured data, optimizing PySpark performance with caching and partitioning, machine learning with PySpark MLlib, real-time data streaming with Kafka. By the end of this video, you'll have a complete set of tools to handle large-scale data transformation, analytics, and machine learning using PySpark in Databricks. Let's jump into the next 15 advanced examples. Part 1. Advanced Data Transformations. 16. Using window functions for ranking and aggregations. Window functions allow us to perform partitioned aggregations, such as ranking employees by salary within each department, without collapsing the dataset like a standard group by. This is particularly useful for financial analytics, sales performance tracking, and customer segmentation. 17. Performing a full outer. Join a full outer join returns all records from both data frames, filling in null values where there's no match. This is useful when combining datasets from different sources that might have missing or unmatched records, such as customer profiles from multiple systems. 18. Exploding arrays and nested data. Many datasets contain nested structures, such as arrays or JSON fields. The explode function flattens arrays, creating one row per element, making it easier to analyze multi-valued attributes like customer interests, purchase history, or IoT sensor readings. 19. Pivoting data for better analysis. Pivoting allows us to transform row values into columns, which is useful when preparing data for reporting dashboards such as monthly sales trends or regional performance breakdowns. 20. Unpivoting data for normalization. Unpivoting reshapes wide tables into long format data frames, making them easier to work with in predictive modeling and time series analysis. Part 2, optimizing performance in PySpark 21, using broadcast joins for small datasets. Broadcast joins send a small data frame to all worker nodes, drastically improving performance when joining small reference tables with large datasets such as currency exchange rates or product categories. 22, caching data for faster reuse. Caching stores the data frame in memory, reducing the need for recomputation when the same dataset is used multiple times. This speeds up iterative transformations and machine learning workflows. 23. Using partitioning to optimize queries. Partitioning physically separates data into folders, making queries more efficient. This is useful for time series data, customer segmentation, and log analysis, where filtering on a partitioned column dramatically reduces scan times. Part 3. Machine learning with PySpark MLlib 24. Converting features into vectors. Before training a machine learning model, numerical features must be combined into a single vector column. This is a crucial step in preparing data for ML algorithms. 25. Standardizing features for ML models. Standardization ensures that all features have the same scale, which improves the accuracy of ML models like logistic regression, SVMs, and neural networks. 26. Training a logistic regression model. Logistic regression is a widely used classification algorithm for predicting binary outcomes such as customer churn, fraud detection, or email spam classification. 27. Evaluating model performance. The AUC, area under the curve, score measures model performance, helping data scientists fine-tune hyperparameters and improve predictive accuracy. 28. Saving and loading a trained model. Saving models enables reusability and deployment in production environments, allowing for real-time predictions on incoming data streams. Part 4. Real-time data streaming with PySpark 29. Reading streaming data from Kafka. Streaming data ingestion is essential for real-time analytics, fraud detection, and IoT monitoring. This command connects Spark to Apache Kafka, a popular real-time messaging system. 30. Writing streaming data to a Delta table. This enables continuous data ingestion into a Delta Lake, making real-time analytics and dashboards possible. That wraps up part 2 of our PySpark in Databricks series, where we explored advanced PySpark techniques, including window functions, performance optimizations, machine learning, and real-time streaming. Now you have a complete toolkit to process massive datasets efficiently using PySpark in Databricks. If you enjoyed this video, make sure to subscribe to Big Data Now and drop a comment on which PySpark feature you use the most. Thanks for watching, and I'll see you in the next deep dive.